If you recall, when you first built the skeleton, you added 3 roll bones to help with the skin deformation of the arm. The idea was that when you rotate the wrist, the forearm roll bones would rotate by amounts that would gradually twist the forearm. Similarly, rotating the shoulder would have an effect on the shoulder roll bone to tone down the skin deformation of that joint. You'll be using a mix of constraints and helpers to produce that effect. Start with the shoulder. Select the shoulder controller and make sure you set the IK-FK blend value to 100 to favor FK action. This way, as you rotate the controller on its x-axis, you can see the shoulder bone react accordingly. The trick here is to have the roll bone rotate as well, but only halfway between the shoulder and the clavicle bones. This way, it will ensure a smooth deformation of the shoulder joint. In order to do that, you will need to create a helper object first. From the Helpers panel, create a point helper in the scene. Name it Zombie Left Shoulder Twist Help. Align it to the shoulder skin bone, pivot to pivot, in position and orientation. Make it a small size. It really doesn't need to be too big. Position constrain it to the shoulder bone so that it travels with it. Next, constrain its orientation between 2 targets, the shoulder bone and the clavicle bone. Now when you rotate the shoulder, the helper rotates halfway between the shoulder and clavicle bones. Now select the shoulder roll bone. At this time, it is simply linked to follow the shoulder bone and therefore reacts to the shoulder's rotation in 1-to-1 ratio. To make it rotate halfway, you first need to ensure it's always looking at the elbow, but still be somewhat influenced by the helper you created. With the roll bone selected, choose Animation, Constraint, Look at Constraint, and then click the forearm bone. You've now set it up so that the roll bone is always looking at the elbow joint. Keep in mind that sometimes, and depending on how the bone system was created, you may need to flip the look at axis. Make a note to remember that when you later work on the character's right side. Try to rotate the shoulder controller. The roll bone keeps looking at the elbow, but doesn't twist with the shoulder bone anymore. Select the roll bone again and go to the motion panel. In the Select Up node section, disable World and select the helper you created earlier as an up node. Try the shoulder controller again. Now the roll bone looks at the elbow, but twists with the shoulder helper, which you already set to twist halfway between shoulder and clavicle. Test it out in shaded mode and with the geometry displayed. Inevitably, you may find you need to go back and tweak the skin deformation in some areas. You can select the offending vertices and adjust them in the Weight Tool dialog. Do not forget to mirror the vertex skin information to the other side before exiting Edit Envelopes mode. Select the shoulder roll bone again and zoom back a little bit. Notice the light blue line displayed in the viewport. This line is an aid that defines the object's look-at direction. You don't really need it to clutter the viewport. In the motion panel, reduce the view line length to a more reasonable value. A value of about 7 should be fine here. Next, zoom in on the arm and select the roll bone closest to the wrist. The procedure is somewhat similar to what you did before, yet a bit different. In a way, it's even easier as you won't need a helper point, only the forearm and wrist bones. Currently, the roll bone is linked to the forearm and therefore doesn't twist when the wrist twists. Use look at constraint to constrain the roll bone to the wrist bone. Use that same wrist as an up node in the roll bone's parameters. The roll bone is still a child of the forearm, but now reacts to the rotation of the wrist in a 1-to-1 ratio. The middle roll bone is the easiest one to set up. It simply needs to be orientation constrained and equally weighted between the wrist bone and the forearm bone. This way, as you rotate the hand controller on its local x-axis, you get a nice gradual deformation of the forearm skin bones. Finally, do not forget to reduce the view line length of the roll bone's look at constraint you set earlier. This covers the rigging of the left arm. You still need to rig the hand, but before that, it is time you run on your own for a stretch. Yes, you guessed it. It is time for you to work on the right arm using what you have learned here. The process is exactly the same, but do not forget to change the script to reflect the names of the right limbs. When you're done, you can then come back and look at the rigging of the hands.